My dear friends, welcome back to BSpice. In this session, we'll continue the International Codes and Standards for Instrumentation. And this session will be part 3. Okay. Prior to this, we have uploaded part 1 and part 2. Part 1 focused on AGA, ANSI, ASME, API, British Standard BS, NLAC, European Norm, EEMUA. Okay. Then part 2 focused on IEC, exclusively for IEC. So both is already in our BSpice channel. Okay. I have given a link of those also. You can watch and get benefited. Okay, friends. And if you are a first time viewer, for info, just for information, in our BSpice channel, we have uploaded around 64 videos. In fact, videos in the sense, not like, short notes or something. Real detailed engineering concepts related to instrumentation. Okay. Pressure, temperature, flow, all these data sheet preparation, design, all these we uploaded. You can, watch and get benefited. Okay, friends. Let's move on with the agenda for this. So we will focus on IEEE, ISA, ISO, JIS, Japanese Standard, then NACE, NAMUR, NEC, NEMA, OIML, NFPA, and finally we wind up with VDA. So these are the focus for this session, part 3. Okay, friends, let's move on. Okay, IEEE. Again, friends, before starting, I just want to give you, see, this is more of a, video to know the relevant codes for instrumentation. Okay, right. So IEEE, Institute of Electrical and Electronics Engineers, right? ISA, International Society of Automation. ISO, International Society Organization for Standardization. Okay. Then JIS, Japanese Standard, Industrial Standard. Then NACE, National Association for Corrosion Engineers. Right. Then NAMUR, very famous in instrumentation, right? NE43. You would have seen all those, in our videos on data sheet and the design aspects, right? Yes. NEC, National Electric Code. Then NEMA, National Electrical Manufacturers Association. Then OIML, International Organization of Legal Metrology. Yeah, this is related to metrology. Then NFPA, National Fire Protection Association. Then the finally VDI, Verenduscher Engineer. It's like a German language. Okay, so it's a bit of hard to pronounce. Yeah, it's basically Association of German Engineers. Okay, so this is the agenda for this, friends. So with this we are winding up. So in fact, as I highlighted in the previous versions, so we have covered A to Z, A to Z. So of course that is not there, but we are covered up to VDA, all standards. Okay, let's move on with the details. First one, IEEE, Institute of Electronics and Electrical and Electronics Engineers. Okay, this IEEE 518 is basically a guide for installation of electrical equipment. What for? To minimize electrical noise to controllers from external sources. So this is the point, very important. 518, it's a guide for installation of electrical equipment to minimize the electrical noise to controllers from external sources. Okay, that's about the IEEE. Okay, 518. Friends, again, I'm telling, I'm only focusing on the international codes and standards relevant to instrumentation. Okay, right. ISA, International Society of Automation, very important. In fact, I'm a senior member of this society. Okay, so ISA 5.1, instrument symbols and specification. So very pertinent to this, P and ID. I don't know whether you have watched the P and ID video, how to read P and ID. So in that we have, specified this ISA 5.1. P and ID means always remember ISA 5.1 for representation. Then ISA 5.2, binary logic diagram for process operation. All these, the logic, whatever we are configuring, right? That is based on 5.2. Okay, right. ISA 5.3. Again, the graphic symbol, we have graphics, all these, right? In the DCS system. Yes, that is based on 5.3. So that's what, everything we have a standard. That's we have been, guided by the standard, and that's what, we are following in the industry. Okay. Then ISA 5.4, instrument loop diagram. This we are going to cover in our one of our session, how to draw loop diagram, all these. Okay. Then ISA 12.4, it's instrument purging of reducing of hazardous area classification. Okay. That's the point. Okay. Right. So ISA, few more. ISA 18.1, annunciator sequences and specification. You would have seen in the control room, right? A lot of annunciation in the panel. Yes, that is in line with 18.1. Then ISA 20, specification form for process measurement and control instrument. Specification form in the sense, the data sheet format, template, all these are. We have to follow this ISA 20. You would have thought like how this developed all this, right? Yes, it's all based on ISA 20, all our data sheet format. ISA 51.1. This is for process instrumentation terminologies. Okay. Yes. Then ISA RP 60.6. This focus on the nameplate, label, tags for the control centers, all these. So everything has a standard. ISA 75.01. Yes, this one we have covered in earlier, right? Yes, it is a control valve sizing equation. Then 75.02. This control valve capacity test procedure. Very important. Capacity test procedure. ISA 75.05. This talks about the control valve terminologies. Okay, right. I hope ISA is very useful, right? Yes. Then ISA 75.13. Okay, method of evaluating the performance of positioners with analog input signal and pneumatic output. This is a 75.13, method of evaluating the performance of the positioner. Okay, right. Then 75.17, control valve aerodynamic noise prediction. Then 75.25, control valve dynamic testing. Okay. Then ISA 20, specification form for process measurement and control instrument. Yeah, it is getting repeated. Never mind. Yeah, good to know again. And see ISA S 84.00.01. This talks about application of safety instrumented system for process industry sector. Okay, application. Okay, friends. Yes. So that's about the ISA. Very interesting, right? Yes. Now we go to ISO, International Organization for Standardization. Okay. What is this ISO 228 Part 1? This talks about the parallel pipe threads. Of course, this is for, our, what do you call, for piping. Yes. Then ISO 10474. It talks about the steel and steel products, types of inspection documents. Okay, right. Then ISO 5167, we all know, right? This is for the orifice. Yes. Orifice plate shall be sized and installed in accordance with ISO 5167. Very important interview questions. Okay. And venturi tubes of circular cross section shall be in accordance with ISO 5167 Part 1.4. Okay. See these two things you remember, friends. 5.1 always 5167 refers to orifice. Okay, 5167 Part 1.4 refers to the venturi. Yes. ISO 5168. Okay, this is the measurement of fluid flow. That is evaluation of uncertainties. Okay, upstream, downstream. We talk about, right? In that there are uncertainty classes are there. So that is in line with 5168. Okay, right. Then few more on ISO 17089. Okay, this is the measurement of fluid flow in closed conduits, meaning ultrasonic meter, for gas meter, for custody transfer and allocation measurement. Okay, So basically it talks about 1089 talks 17089 talks about the measurement for a fluid flow in closed containers. Okay, example ultrasonic meters for custody transfer. Right. Then ISO 6976, it talks about the natural gas, meaning the calculation of calorific value, density, relative density, and Vob index, or a composition. All these are okay. 6976. This talks about the calculation of calorific, right? Yeah, calorific value, density, and yeah, Vob index for composition. So basically, you may be having a doubt on this Vob index. Basically, it's an indicator of interchangeability of fuel gases such as natural gas, LPG, all these actually. So this actually talks about the indicator for the interchangeability of fuel gases. That's a terminology, the meaning. Okay. Then ISO 9001, this we all know, quality management and quality assurance. Then ISO 15848, this focus on the industrial valves. Basically, this is a procedure for the fugitive emission. Yeah, I'm planning to, in fact, what do you call, conduct a session for this fugitive emission also. I don't know whether you have watched this control valve design and the data sheet preparation. In that, I have covered extensively on this topic actually. What is fugitive emission, all these. Okay, friends, if you have not watched, you can watch and get to know. If anything, if you want, you can, comment in the comment section. Okay. Then ISO 11064. This talks about the ergonomic design of control centers. In the control room, the console, the chair, table, all these are all actually in line with that actually. 11064. Yes. So that's about the ISO. That is also very interesting. Then we'll talk about JIS, Japanese Industrial Standard. Okay. Yeah, this C0903 1983 version. Okay, forget about the version, year and all. So basically C0903 talks about the electrical apparatus for explosive atmosphere in general industry. Yes. That is the JS. Then NACE. Very important for us actually. You would have seen in our data sheet, right? NACE application. Yes. National Association for Corrosion Engineers. So basically NACE MR0103. It focuses on the material resistant to sulfide stress cracking in corrosive petroleum and refinery environment. Okay. Yes. I hope this is also clear. For example, when tubing is in contact with process stream identified as a source service. What is the source service? H2S. Okay. So the requirement from NASA MR0103 shall be included. Yeah, that's it. Then for source service, NAS MR0175 Part 2. Instrument piping shall be provided with resistance to sulfide stress, corrosion cracking, and where applicable resistance to hydrogen-induced cracking. Basically, okay, see, when it is in a source service, we should go for this MR0103. Okay, then if there is instrument piping which we need to provide resistance for the sulfide stress corrosion cracking and also hydrogen-induced cracking, we should go for this specifically 0175 part 2. That's it, friends. As simple as that. Okay, right. Then NAMUR is very important and very famous also, right? We in fact, in one of our video, we covered this actually. I think this is mastering pressure transmitter, right? So you can watch and get benefited also. I covered in detail. So basically, it talks about the standardization of signal level for the failure information of digital transmitter. Whether it is, the failure is due to the process or it is related to the hardware, all those information depends on the amps rating, 3.6, all these are 4 milliamps, 20 milliamps, and below 4 milliamps, 3.6, and above 21.6, all these are. Okay, I don't want to go into detail here, but you can get watch and get benefited. This is about the NAMUR. Okay, Then NEC, National Electric Code. Okay. This one, NEC, we have a 725M. It talks about the cable installation on cable tray. This is the one of the point actually for NEC. Okay. Then we have NEMA, National Electrical Manufacturers Association. So we have NEMA VE1. It talks about metal cable tray system. Okay. It basically focuses on the cable tray. Then NEMA VE1, cable tray installation guidelines. So it talks about cable tray system, cable tray installation guidelines. Then this we know, right? ICS 6. This talks about the enclosure for the industrial control and system. All these, cubicles, panels, junction box, local control panel, all this comes under that. This is about the NEMA. Okay. Then OIML. This is actually a little bit very different, but related to this legal metrology. It's International Organization of Legal Metrology. So what it actually covers. See, OIML or 117, it talks about measuring system for liquids other than water. That's the point, friends. Measuring system for liquids other than water. Then we have one more, or 140. It talks about measuring system for gaseous fuel. That's the point here. These are the OIML. Then NEC, National Fire Protection Association. I think, sorry, this is a typo error. NFPA. NFPA. Sorry. National Fire Protection Association, NFPA. Okay. NFPA 10, portable fire extinguishers. NFPA 10 talks about portable fire extinguishers. Okay. Then NFPA 11. Okay. It talks about low, medium, and high expansion foam. Okay. Low, medium, and high expansion foam. Then NFPA 13 talks about installation of sprinkler system. NFPA 13 talks about installation of sprinkler system. Okay, yeah. Then NFPA 15, it talks about the water spray fixed system for fire protection. Water spray fixed system for fire protection. Then NFPA 20, it talks about installation of stationary pump. NFPA 24, private fire service mains. Private fire service mains. Then NFPA 30 talks about flammable and combustible liquid code. Flammable and combustible liquid code. So that's about the NFPA. And we have few more. Again, sorry for this typo error. Yeah, NFPA 72, very, very important. National Fire Alarm Code, 2002. Forget about the version, but NFPA 72 talks about the National Fire Alarm Code. This is basically National Fire Alarm and Signaling Code as applicable for the fuel, fire and gas system. Okay, FGS. Very important for us, friends, instrumentation people. Yeah. Then we have 1901. It talks about the automotive fire apparatus. Automotive fire apparatus. Then NFPA 497. This focused on the practice for the installation, classification of flammable liquids, gases, vapors, and of hazardous location for electrical installation in chemical process area. This NFPA 497, friends. It's a recommended practice for the classification of flammable liquids, gases, vapors, and hazardous location of electrical installation in chemical process area. So that's the point here. Okay. Then we have 497A. This actually recommended practice for classification of class 1 hazardous location for electrical installation. Class 1. Okay. Right. Then the final one, VDI, very industrial engineer. Okay. Basically VDI, VDE 3513 black one. It's actually focused on the variable area flow meter calculation method. Yes, that's it, friends. I hope I covered all the codes and standards for instrumentation from A to Z. Of course, not Z, up to V. Okay, friends. So yeah, thanks again for your support. And only 2 requests from my side. If you like this all the 3 parts, section 1, 2, 3, you just press the thumbs up button and subscribe. If possible, you share with your friends so that it will reach others also. Okay, friends. Thanks once again. And next, coming up, very interesting topic, heart versus foundation field bus. Till then, this is Ram Bala signing off. Bye bye. Take care.